Right now I'm at. It's TP, but you know what? It works. And it kind of gets us into having to be economical with it. I got you. Oh yeah.
One question left, and I was like, my brain couldn't figure it out.
That's what that's for. That's 100% what that's for. Okay. Let's look at this, because we are going to be continuing to do our solving. Now we have things that have equal signs in them, so we are able to get all the way down to solutions, down to x equals. In our first chapter, we couldn't get down to solutions or x equals because we didn't have equal signs. We were just looking at expressions. So now we have these equal signs. Now we're getting solutions all the way down. So let's take a look at this one here. This first one on the left, we've got the group of x plus 3 times 2x minus 5. And we've got that set equal to x times the quantity x minus 6 plus 1. So when we're looking at situations like this, simplify each side. So don't initially start crossing the equal sign unless that's really the only thing we can do. Simplify each side individually first. So when we're looking to multiply this side out, what are we going to get? How do we multiply this left side out? I'm just going to zoom the page in. We're going to need to do some distributing here. We have the x times the 2x, getting our 2x squared. X times the minus 5, minus 5x. Got our 3 times our 2, so we've got a 6x. And 3 times the minus 5, minus 15. If you do that and combine your like terms at the same time, that is 100% okay. If you do this separate and then combine your like terms, again, totally okay. I'm going to also simplify the right-hand side because I don't want to have to write things 5 million times. So on the right-hand side, we also have a distribution. It's just a single distribution, not a double. So we're going to have our x times x giving us an x squared. And an x times minus 6 giving us minus 6x. And then that plus 1 is just kind of tacked on the end. I'm going to change it on a different color. Plus 1. There we go. So then I'm going to combine my like terms together just because I like to do so before we try and solve stuff. Do our 2x squared minus 5x plus 6x. We get a plus 1x. You can either put plus x or include the 1. It genuinely does not matter. It means the exact same thing. And then what should we do? How can I go about trying to solve this? We need to set it equal to 0 because we've got x squareds here. So what are we going to do? Minus an x squared. We can do more than one thing at a time. We can also add our 6x to both sides. And we also want to move that 1, so we're going to subtract 1. If you want to do these in separate steps, again, totally okay. We can also do these in one single step. That's totally fine, or some blend between. But we're just trying to get this thing to equal 0. So our 2x squared minus x squared gives us just 1x squared. Our 1x plus 6x gives us a 7x. And our minus 15 minus 1 gives us a minus 16. And that's going to equal, my x squared cancels out, my 6x cancels out, my 1 cancels out. There is nothing left over here. To say, because we're trying to find solutions. I want to get all the way down to an x equals. So we'd love it if we could factor this, right? Always a good idea to check and see. Is there a pair of numbers that's going to multiply to make negative 16 and add to make 7? No, there's not. I was going to say the closest we get is like an 8 and 2 situation, but 8 and negative 2 would give us a 6, not a 7. So if I have a quadratic and it won't factor, how else can I find the solution? Quadratic formula.
Oh, yeah.
So this is one of those things that we are going to need to know. There are so many songs on YouTube. If you do not know this, I highly recommend checking some of it out. There are covers of so many songs about our x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the classic one, is Pop Goes the Weasel. I have seen covers for Dre. I've seen covers for Eminem. I've seen covers for, I think I've seen one of Taylor Swift, but I didn't look that close because honestly, I didn't want to kill it. They are epically cringeworthy. So, great tool if we are not confident in our quadratic formula. There are some cringe-tastic videos. If you have fallen to a place where we're not sure what to watch on YouTube, oh, check them out. They're so, like, it's that cringe that you go, oh, I can't stop watching. Some of them are epic. They're clearly been assigned as extra credit projects to, like, 8th graders. Like, oh, they're cringy. Oh, they're cringy. It's good, though.
It would be fun if they were actually like.
Oh, there's one where they've done Superman. 2A, 2A. Oh, yeah. There's choreography in the stairwells of the school. I'm just saying, like, they're good. They're bad good, but they're good. Okay, so using our quadratic formula, we can find our answers for this. What is our A value? 1. What is our B? 7. And what is our C? Negative 16. So we plug those pieces in. We have our opposite of 7 plus or minus the square root of our 7 squared minus 4 times 1 times 6, negative 16, all over our 2 times 1.
Oh, Lordy.
And we have tools we can use. So our x equals, simplifying things we can, negative 7 plus or minus 7 squared gives us 49. Negative 4 times negative 16 plus 64 over 2. Bless you. What is 49 plus 64? 113.
Could you slow down?
Oh, yep, sorry. I get excited. Yep. We're just multiplying these together. Our 7 squared gave us 49. Negative 4 times 1 times negative 16 gives us 64. And then we combine those together. Is 113 a nice, pretty square?
No.
No. That is not one I know off the top of my head. I know it's smaller than 121, which is 11 squared, and more than 100, which is 10 squared. So it's somewhere between 10 and 11. But other than that, I got nothing. Does it have any factors that we see that are perfect squares or that we could test? Because it definitely does not divide by 100, so it's not going to have 10 squared in there. It's not going to divide by 81. It's too big for that. Work your way down. It's not dividing by 64. It's too big for that. Doesn't divide by 49. It doesn't divide by 36. Our easy way to check for our 3's is if the digits add up to something divisible by 3, it will be divisible by 3. So 1 plus 1 plus 3 is 5, not divisible by 3. So it will not be divisible by 3, 6, or 9. So check, that's the easy way to check it. You can also use a calculator and check it. We have access to those for a while. That's our answer. If you want to split it apart, you can into our negative 7 plus square root of 113, negative 7 minus square root of 113, but we can also leave it as our plus or minus. Totally valid. More often than not, we will have things that are factorable, but occasionally we'll see some icky things. Questions on this one? Okay. Our next one we're going to look at is this guy. So we get 3/4 x plus 5 and 2/5 x minus 1. And I know our first instinct on this is to go, ew, fractions. Gross. If you want to rock on with them as fractions or put them as common denominators, totally valid. Since I have an equal sign and I have where I can do the same thing on both sides, I can get rid of all the fractions. How can I get rid of the denominator 4? How can I get rid of that? What if I wanted to get rid of this? Multiply by 4. If I multiply absolutely everybody by 4, that's valid. As long as I do the same thing to both sides, I can do whatever the heck I want. So if I multiply both sides by 4, that's going to give me my 4s are going to cancel out, so we're left with a 3x plus 20 equals 2 times 4 gives us 8/5 x minus 4. And I got rid of one of my fractions. Yay! Because I know for a lot of us that makes us way happier. But now I can get rid of the 5th in the exact same way. So you can do them in 2 chunks like this. If you want to just multiply by 20 and get everybody done at once, totally valid. As long as I do the same thing to both sides, I can do whatever I want. There's going to be things that are more helpful than others. But if I want to get rid of those fractions because I don't like looking at them, that's totally valid. As long as I do it to everybody, I can do anything I want. I could multiply everybody by 7 if I wanted to. I wouldn't because it makes things harder, but I could. And this way we can get our denominators out of here because it makes us more comfortable. If you are ready to rock and roll with your fractions, totally valid. You should get the same exact answer as me. But you don't have to make your life harder and work with the fractions. We can get rid of them and get down to 15x plus 100 equals 8x minus 20, which is equivalent to this equation up here. They're going to have the exact same answer. I just made it so we didn't have fractions down here. Again, you don't have to do this, but it's an easy way to go. Especially if we are one of those, or if we are an anti-fraction person. I do my best to accommodate the anti-fractions. So let's take a look at this guy. What do I do to solve this one? Subtracting 8x is a great choice. Not the only choice, we have lots of options. If we always move the smaller x, we will wind up with the least amount of negative coefficients. But we know how to rock with negatives. We can do that.
Do we?
Yeah. Since I don't have any squares, we're not trying to get this thing equal to 0. I want to get to an x equals a number. So we can also subtract 100 at this point to get our numbers over to the right side. I do not care if you put your x's on the left and your numbers on the right. If you put your numbers on the left and your x's on the right, I don't care. It makes no difference. They mean the same thing. But we should get down to our 7x equals negative 120. Because our 8x is canceled out here and our 100 is canceled out here. So what is x going to equal? Mm-hmm.
How much do you want to round?
Put it as a fraction. We can put it as a fraction.
Okay.
Negative 120 over 7. And it doesn't simplify any further. If you want to put it as a decimal, it's not going to be pretty. We would have to round. And if we're needing to round stuff off, I would say give me at least 3 decimal places.
Okay.
But fractions are more accurate. Because that is 100% right. Negative 17.143 is mostly right. So I'd rather us have it as fractions, but if we are significantly anti-fraction, I get that. So then I've got both of those up in their entirety. Questions on either one of those? Now let's look at one of these ones.
Ew.
I know. Some of our fraction-y friends. Yay! So let's look at this one on the left here. I've got 3 over 2x plus 5 equals 7 over 2x minus 4. And you can think about this and dealing with the fractions the exact same way we dealt with our 4th and 5th on the previous one, where I multiply by whatever's in my denominator to get rid of my fractions, which I totally can do. If I multiply both sides by my denominator, so I'm going to multiply both sides by my 2x plus 5. This one and this one are going to cancel out. And then to get rid of the other fraction, I'm going to multiply both sides by this denominator. So you can do them at the same time, or you can do them in 2 separate steps. I'm going to do them in 2 separate steps just so that it's clear what's going on here. Because this is going to give us our 3 equals, do this, 7 times our 2x plus 5. I'm just leaving it like this, over our 2x minus 4. So I'm doing this in 2 steps. You can really do this in 1. Because now what I'm going to do is I'm going to multiply both sides by this denominator times the 2x minus 4 times 2x minus 4. This side and this side are going to cancel out, or that denominator is going to cancel out. So we wind up at 3 times 2x minus 4 set equal to 7 times 2x plus 5. Which, if we're thinking back to when we first learned how to deal with the fraction equals a fraction things, and a lot of times we thought about the butterfly. Yes, dear.
The second step, why don't you put the 2x plus 3 in the denominator too? Like when you're multiplying both sides, it would be like both in the numerator and the denominator.
Are you talking here?
Yeah.
Because when I multiply both sides, so that will cancel out. This is 7 times this guy. And then I'm choosing to multiply by this piece to get rid of my denominator. So the step we got when we multiply this, you could like distribute this out. We're not multiplying by a funny looking 1. That I would only need to do on both if I was only multiplying one side. If I did not have an equal sign, if this part wasn't here and I just wanted to like get rid of the denominator, then I would have to multiply by a funny looking 1. But since I've got the equal sign, as long as I do the same thing on both sides, I don't have to keep the denominators.
So you would have to multiply by both the numerator and the denominator.
Correct. Because I would still have denominator stuff with variables, and since we're trying to get to an x equals, I want all those x's in the numerator. So when we first started working with these, you might think of this as cross multiplication or as like butterfly method, was a lot of times the name they used. Where like you do like the x with the circles. The reason I like to do it like this is it makes it easier when we look at the next ones if we think of multiplying by the denominator. So you can think of it as butterfly, but it makes it easier when we do the next step if we have them separately in our heads. So we should get down here. This is equivalent to what's at the top. It's just a little easier to work with. Because now we have 2 sets of distribution that we can do. 3 times my 2x and 3 times my minus 4. We're going to have our 6x minus 12. And we're going to have our 7 times the 2x, 14x, and 7 times the 5, which is 35.
I almost said 34 for some reason. I don't know why.
I have 100% done that and written it down. It happens. Our brains make interesting choices, which is part of the reason we write stuff down and show work, so that I can tell if we just accidentally wrote down 34 or whatever, instead of going, where did we get lost? I don't know how to help. So when you write things down, I can see where something went wrong, and I'm like, oh, we just made a mistake when multiplying, not we have forgotten how to distribute. Okay? So this is why we have to show the work. It lets me see where our glitch is happening. What do I do next to solve this? Minus 6x is an absolutely valid way to go. Again, not the only option. It's just the one that gives us the least amount of negatives we have to deal with. We can also move our number at the same time if we want to. Minus the 35. Again, you can do this in however many steps you want to. Doing it in one step like this does sometimes make it less writing. So we're going to have our negative 47 equals 8x and what is our answer going to be? Negative 47 over 8. If you are, again, anti-fraction, it would be negative 5.875. You can put it as negative 5.875. There's not even any rounding on that one, so that is still 100% accurate. Negative 5.875, totally valid. Whenever we have our original question that has x's in the denominator, we have to check it to make sure it's not extraneous. Sometimes when we have x's in the denominator, things go wonky. We'll wind up on an asymptote, we'll wind up in a discontinuity, things happen. So if my x was this negative 5 point decimally grossness, will either of these denominators be 0? No. Because if I had 2 times 5 in decimally goodness, plus 5, not 0. All I care about is it 0? 2 times 5 and change, and then minus 4. 10-ish minus 4, also not 0. We don't need to know what the value would be. We just have to check and make sure it's not where we have a problem in our denominator. So it is important to check whenever our original problem has an x in the denominator. So if we have an x down here, you gotta check. This is, in fact, a valid solution. So you can either write it as a fraction or as a decimal. I genuinely do not care. But we've got to check when x is in the denominator because it could be extraneous. Okay. Questions on this first one on the side? Because we're going to do another one. So here's our next one we're going to do. We've got negative 5 over 3x minus 9 plus 4 over x minus 3 set equal to 5 over 6. Yeah, this first fraction has the greatest common factor in the denominator. So I'm going to rewrite this real quick as our negative 5 and rewrite this as 3 times x minus 3. Plus our, I don't know why I changed colors there. There we go. Plus 4 over x minus 3. And that's equal to 5 over 6. And what we want to do is we want to multiply everything by the pieces that are in the denominators. Because I'd like to get rid of all of these denominators. Yeah. So I know I'm going to need to multiply by the x minus 3 that's here. We need to make sure we include a 3. And we need to make sure the 6 is going to cancel out as well. So if we think about this in terms of when we were adding these fractions together and we're just kind of simplifying, if I looked at just these 3 fractions, what would our least common denominator be? If I just wanted to get common denominator between all 3 fractions. And with the x minus 3, I was like, you can absolutely use 18. It is not the least, though. 6. Because the 3 is a part of the 6. 6 is 3 times 2, right? So the least common denominator between all three of these fractions would be 6 over x minus 3, or 6 times x minus 3. You could get them all to common denominator, add the 2 on the left together, and then do exactly like we did on the previous one. Or we can come through and multiply all these pieces by our 6 times x minus 3, whatever our least common denominator would be, times 6 times x minus 3, times 6, I'm out of space. Hold on a second, I'm just going to jump for a second. There we go, just need to give myself a little more space. X minus 3. Because then when we come through to simplify this, the x minus 3 cancels out with this x minus 3. And this 3 is going to cancel out and leave us with a 2 up here. Here my x minus 3 is going to cancel out with the x minus 3. And here the 6 is going to cancel out the 6. So a lot of the pieces are going to cancel out, and we're going to wind up with no denominator. Bless you. So when we come through and try and look at this and simplify, we ignore all the things that have been canceled out. We're going to have our negative 5 times 2 is the only thing that's left up here. So that turns into a minus 10 plus 4 times 6. That's the only thing left on that one. It's going to be a 24. And that's equal to 5 times x minus 3. Which I'm going to do this distribution while we're here. If you want to do that in 2 separate steps, again, totally valid. But we're going to get 5x minus 15. Okay? So when we have especially more than 2 fractions, more than just 1 on each side, multiply everybody by everybody's least common denominator. That'll get rid of all of your fractions in one go. So when we're down here looking at these guys, or what we have left over, we're going to combine our like terms. So we should get 14 on this side is 5x minus 15. What do we do next? Add 15. That's going to give us 29 equals 5x. So what is x going to equal? I don't know off the top of my head, that's a decimal. Sweet. You can do it as 5.8, or you can put it as our 29 over 5. Again, it doesn't really matter which way you put it. Both are exactly as accurate. Since we did start with x's in our denominator, we've got to check. If I put 5.8 in place of this x, is my denominator going to be 0? No. If I put 5.8 in place of this x, is my denominator going to be 0? No. There's not even an x in that denominator, so we're good to go. But whenever there's an x in the denominator, it is important that we check. Okay? We are going to, as I say, questions on these before I change the page again. Because there's another kind of question in this section, and so we're going to do like a bounce back and forth between that kind of question, we'll do more of these, do that kind of question, we'll do more of these. So I want to make sure we get a chance to see everything before we get to the weekend. So the other kind of question we see in section 2.1 is when it says solve for a specified variable. So you're going to wind up with an equation that looks like an equation. These are not going to get better. They, in fact, may look worse. So it'll give you an equation, and it'll tell you a letter. So this one says R equals V over L. That is a v. A lot of times the lowercase v's and the lowercase u's look very similar, which is really fun on the problems when they use both u and v. It happens. So we just got to be really careful. And they want us to solve this for L. What that means is we are trying to get down to an L equals. That's our goal, is to get to L equals. I always write my L as kind of a cursive L. It stops it from looking like a 1. I will do that every time. So since we're trying to solve for L, I'm trying to get to an L equals. What can I do to get L by itself? Multiply both sides by L. All right. I need the other conversations to stop. It's very distracting. Thank you. So we're going to have up here our L times capital R is equal to V. The L cancels out over here. But I don't want to have LR equals. I want to know what L equals. So what do? Divide by R. So we're going to have that our L equals V over R. So this one winds up looking very, very similar to what we started with, but this is our answer. We're going to do another one. So look at the one on the right. And I'm going to grab this one. So. There we go. There we go. It's going to blink. There we go. Uh-huh. Oh, this is an equation we know. What? This is the volume of a cylinder, or of a pyramid. Come on. That's okay. You don't have to know what it's for.
It's been 2 years.
It's been a while. We don't need to know what it's for. But we want to solve this for h. And in fact, I believe all of the equations I give you are a formula we should hopefully have seen before. The first one was, I believe, a velocity thing in physics.
Yeah.
It's okay. So we want to solve this one for h. How can I get h by itself? Yes, we could divide by 1/3 pi r squared. When we're dividing by a fraction, though, it gets kind of gross. So I'm going to recommend that we divide by the things that aren't fractions. Totally valid. Like, if you want to do that, that's fine, but you will have to remember how to simplify that. So I'm going to divide both sides by pi r squared. Totally valid. These guys are going to cancel. So we're left with v over pi r squared equals 1/3 times h. How do I get rid of that 1/3? Times 3. Whoa, that 3 is backwards. Wound up mirroring myself. If we multiply both sides by 3, that's a little easier to keep track of than dividing by 1/3, because we should wind up with 3v over pi r squared equals h. And once we get that variable they've told us to solve for by itself, we're done. That's where it is. I want to look at one more like this so that we can kind of see what's going on, because some of them are a little kind of gross. Like this one. So we are taking this S equals P over Q plus P times Q minus 1. Or 1 minus Q, sorry. And we want to solve it for Q. Means I want to get to a Q equals. Right now I've got Q's in denominators, and I have more than one Q. Gross. So what we're going to do with this is we're going to go, ew, fractions first. And say, be gone with the fraction. Multiply by our denominator to get rid of the fraction. As long as I multiply both sides by the whole denominator, we're fine. I'm just blocking that on the full page. There we go. So I'm going to multiply this side by our q plus p times. Do you guys have a question? You guys whisper loud, just so you know. I can hear it up here all the way, so everyone between us can hear you whisper too. Just being clear. So I'm multiplying both sides by that entire denominator. And I know it's gross. That's okay. This guy and that guy go away entirely. Huzzah. Yes, dear.
Oh,
What's up?
is q plus p a variable, or is it q plus p times 1 minus 2?
It is q plus p times 1 minus q. But we've got two q's, and we still want to get to a q equals. So I'm going to need to get those together at some point. I'm going to show you how to do it, I promise. Because what we have here right after we multiply is we get our s times q plus p times 1 minus q. So we get these too many parentheses here equals p. And that left side's a mess. Let's do all of our multiplying out to make this not have any parentheses. That's going to be our first thing we need to do. I want to get my q's together, so we know we're going to need to multiply these pieces out. Do I really want to have an s with my q, or do I want to be rid of my s? Rid of the s. I don't want to have to distribute the s when I have all this other multiplying and adding to go together. I can divide by s on both sides. That'll get rid of this guy. I need to get my left side simplified, but that doesn't mean I have to distribute everything. I don't want an s in my answer, so get rid of it. I need q's, so I need my q's together. So I can't get rid of my q's, but I can get rid of that s. That gets rid of one of our sets of parentheses already. So we've got our q plus p times 1 minus q equals p over s. Now I have two q's, so now we're going to need to do some multiplying. Now we're ready to distribute. We're going to have our q plus p times 1, just gives me p, minus q times p equals our p over s. Okay, changing the view. There we go, just making it bigger. Questions on that step? Because I'm trying to get the q by itself, so I need to keep my q, and I need to keep my q, but anything that doesn't have a q needs to go over there. So I want to get rid of this p and send him yonder. So I'm going to subtract a p. I keep the things that have the letter I'm looking for. Everybody else goes to the other side, so I'm going to minus a p from both sides. So we're going to have q minus qp equals p over s minus p. Don't just cross out the p. You can think of it as 1/5 minus 1. Like, it's not the same thing as nothing over 5. How can I get a q by itself here? If I have q minus qp. Factor out a q. Divide out a q. I want one q. Think of it like a GCF. If I factor out a q, we get q times 1 minus p, right? That means the same thing. And then I can get my q by itself. So if I have q in more than one space, or whatever letter I'm looking for in more than one space, factor it out. Because to get this by itself, I need to divide both sides by that 1 minus p. So we're going to wind up with this super gross q equals p over s minus p, all divided by 1 minus p. Whoop. Up here, GCF, q, 1 minus p. Factor it.
Then I divided both sides by this denominator, or by this piece, to get my cube x off. Okay? See that? As long as you switch it back at the end, or at the very, very top, tell me that you've said, okay, x equals p, y equals q. That's fine. So you just make it clear. Just don't randomly switch it and don't tell me what things are.
Yeah, so if you took
Okay? Have a great rest of your day. Have a great weekend. I'll see you Monday.